So open and short circuits. So this is one of the important concept. Okay, so open circuit and short circuit. So in that case, what happened in the network? Okay, under an open circuit between A and B means current zero. So just like open switch, no? Open switch is open means no current flow into the load. For example, fan. Okay, the switch off means there is no current flow into the fan. That's why the fan is not working. Am I right or not? That means under open circuit condition, no current is passing through the load or device. Okay, that means current is I is equal to 0. Okay, voltage across an open circuit any value. Okay, ideally supply voltage. Okay, open circuit across the switch ideally same as supply voltage. Okay, so an open circuit is an equivalent to resistance infinity. It's clear? Okay, an open circuit is an equivalent to resistance of infinity, ideally infinity. So under open circuit condition, no current passing through the device. No? That means you know well according to the Ohm's law, R is equal to V by, am I right? R is equal to V by I. So I means 0, I is equal to 0 means 1 by 0, V by 0 is infinity. Under open circuit current condition, the resistance is infinity. Understood? The resistance is infinity under open circuit condition. Okay, then short circuit. A short circuit between A and B means under short circuit condition. Under short circuit condition, what is the voltage across the device? 0. Voltage 0 under short circuit condition. Current is maximum. Current through the short circuit is any value, ideally maximum, infinity. Okay. At short circuit is equivalent to resistance of 0 ohms. So R is equal to V by I. So with 0 by something 0. No? So that's why under short circuit condition, what is the resistance? 0. It's clear. An open circuit condition, current 0, voltage ideally supply voltages are maximum voltages. Okay, and resistance is infinity. R is equal to V by I. Then I is equal to 0. 1 by 0. V by 0 is called infinity. And then in short circuit terminals A and B means under short circuit condition, the voltage 0. Okay. Current through the short circuit is any value. Okay. That may be maximum, ideally maximum, infinity, maximum current flowing through the element or device under short circuit condition. Use amount of current is passing through the device under short circuit condition. Okay. So that means the resistance is 0. Short circuit is equivalent to a resistance. It's clear. And then coming to the conductance concept, we sometimes prefer to work with the reciprocal of resistance, that is called 1 by R. Conductance means 1 by R. G is equal to 1 by R. Conductance is denoted by G. Okay. Conductance is denoted by 1 by R, that is called G, which is called conductance or symbol G or units Siemens or mho inverse, ohm inverse or mho. Okay. A resistor R is conductance, G is equal to 1 by R. Okay. The IV equation Ohm's law, according to the Ohm's law, so like this, I is equal to G into V. So nothing is there. G, substitute G is equal to 1 by R, I is equal to V by R, same as Ohm's law. No? I is equal to V by R. So 1 by R is nothing but G. That is the conductance concept. Okay. Next, sources here. So the sources can be classified into voltage source and current source. Okay. The next concept is sources. The sources are classified into voltage sources and current sources. Again, these voltage sources are classified into ideal voltage source and practical voltage source. All of you draw this. All of you write sources, voltage sources, and current source. Under voltage source, ideal voltage source, first one, and the second one, practical voltage source. And the current sources, under current source, ideal current source and practical current source. So you have to classify the sources like this. It's clear? Under voltage source, ideal and practical. Under current source, ideal and practical. Okay. So try to consider here. So ideal voltage source. How to represent ideal voltage source? So what is the characteristics of ideal voltage source? Okay, this is called battery. The battery is nothing but source. No? So we have to indicate the sources are like this. Two ways. Both are correct. So we have to indicate in a circuit like this manner. Okay. So A and B, this is called one terminal. One is called another terminal. This is called plus and this is called minus. And here also A and B, two terminals. Any sources having two terminals. No? Okay. So they have to represent so like this manner. So that means there is no resistance element in the circuit. There is no resistance part in the circuit. Okay, that's why the voltage across the terminal A and B is equal to the supply voltage. It's clear? The voltage across the supply A and B terminal, VAB is nothing but V only. There is no voltage drop across the A and B terminals. It's clear? There is no voltage drop across the A and B terminals. So whatever the voltage supplied by the source is equal to the voltage across the A and B terminals. Between A and B terminal, so whatever the source supplied energy will be equal to the across the A and B terminal. Same. Okay, there is no voltage drop. Ideal voltage source. Okay, V versus I characteristics. When you are taken V versus I characteristics, so the voltage is independent of time. Okay, independent of time. So this voltage versus time or current voltage versus current. This independent of time. The voltage is constant throughout the circuit. So there is no voltage drop here. So here, starting initially, V volts. After certain time also, V volts only. Okay, that means there is no voltage drop across circuit input. Okay, so this is the ideal voltage source. So this is the circuit configuration of ideal voltage source, and these are the characteristics of ideal voltage source. Voltage versus time or voltage versus current. This these are the characteristics we have to get. Okay, this is ideally. Then practically, this is the voltage source having some resistance, internal resistance R. It's clear. Ideally, there is no resistance. There is no resistance part. But practically, it's having some internal resistance that is denoted by small r. This is the supply voltage source V, and this called internal resistance R. But here, across the A and B terminals, there is a drop in voltage. Okay, some small amount of voltage drop across the A and B terminal. This A and B terminal voltage is not equal to the supply voltage. It's clear? In between A and B terminal, that is called VAB is not equal to the V. It's clear? Understood? Because of internal resistance of the source, that is called R. I into R. So I into R is called voltage drop. Okay, because of internal resistance, there is a small amount of voltage drop takes place here. Okay, that means, so what is the VAB here? V minus I into R. So this total voltage minus this drop is called VAB. V minus I into R. This is called V is equal to I into R. Na? What is the voltage across the resistor? V is equal to I into R. I into R is called voltage drop across this resistor. Then what is the voltage here? In between A and B terminal? V minus I into R. So that's why the voltage is decreasing. The voltage is decreasing. For example, here 20 volts. Let us assume 20 volts. Here voltage is nothing but maybe 19 volts or 18 volts. Am I right? It's not equal to the supply voltage. But ideally, okay, supply voltage is equal to the across the A and B terminals output voltage. Okay, so there is no resistance here. That's why there is voltage drop across here 0. That means ideally internal resistance of the voltage source is 0. So that is the main point. All of you write ideally the voltage resistance, the resistance of the internal resistance of the source is 0. Ideally, it's clear. Ideally, internal resistance of the source is equal to 0, but practically it's having some value, any value. So that's why. So try to consider these characteristics of voltage versus time of ideal voltage sources like this. Is not equal to the, so yeah, VAB terminal. across the voltage across the VAB terminal. This is not equal to the supply voltage. So here some drop is there. No? There is the drop is called I into R. Right here, this drop here to here is called I into R drop. It's clear. So here V voltages, here VAB voltages, A, B terminals here, and it is called supply voltage. So some amount of drop I into R. Because of that, this drop, this voltage, output voltage across this A and B terminal is not equal to the supply voltages. Understood? Not equal to the supply voltages. That is the problem we are facing. That means in order to supply the high voltages to the load, what we have to do? We have to maintain the internal resistance of the source is minimum. Then maximum voltage can be supplied from source to load. Am I right or not? We have to maintain the internal resistance of the source must be minimum. Then only the supply voltage is equal to the output voltage of the source. It's clear? And then current source, coming to the concept of current source. Coming to the concept of current source. Understand? The current source ideally is like this. Ideally, current sources we have to connect like this manner. Arrow indication is called current source. So we have to indicate two ways, both are same. Okay, in between A and B terminals, we have to indicate like this. Okay, and here this is the characteristics of current source. Ideally, this is concept only belongs to ideal conditions. Okay, the ideal current source is having there is no resistance. There is no resistance part in the ideal current source. A and B. So what is the current here present on this here source? That current is completely passing through the circuit like this. Okay. So what is the current across the A and B terminal? If you are connecting one load here, the current passing through the load is equal to the current supplied by the source. It's clear. Current passing through the load. This, for example, if you are connecting one fan here, one resistive load, one heater, one TV. So the current across the device is nothing but current supplied by the source. That means, so whatever the current supplied by the source is equal to the current passing through the load. That is called ideally. Okay. So ideal current source characteristics are like this: current versus voltage or time in hours. That means current passing through the load is constant, is not changing with respect to time, with respect to voltage. So that means current characteristics are like this straight line. Okay, so any time the current magnitude is always constant. Okay, so this is called ideal current source. Then practically, so the current source is indicated like this manner. Practical current source we have to indicate like this manner. Okay, practical voltage source in series with the resistor, voltage source practically some resistance in series with the voltage source, but current source in parallel to the resistor source. Okay, in parallel to the one resistor, you have to connect to the current source. The current source is connected one resistor that is called parallel resistor. Okay, because of that, what is the characteristics are like this? So, for example, here current I, the current I entering like this. Okay, some of the current passing through this device, this resistor, this internal resistance RS, maybe so indicate RS or small RS, source resistance of the current source. Okay, so the current is entering from the source like this and passing through the load, but is having some internal resistance now. Because of that, the current some amount of the current some amount of the current is passing through the resistive device. Am I right or not? Okay, that's why there is a drop in current. There is a reducing of current magnitude. We have to observe across the A and B terminals. That's why the current after certain time, the current is decreasing. So this is the magnitude of current up to here. This is the magnitude of the current up to here. But here the current magnitude is decreasing. For example, here 10 amps. Let us assume 10 amps. Okay, across this terminal, maybe 8 amps or 5 amps. Okay, some amount of current is passing through this. So how to get maximum current across the load? How to get maximum current passing through the load? By maintaining the internal resistance of the current source is maximum. No? Here we have to maintain the internal resistance of this source is maximum. Then only the current is passing through the to the A and B terminals is maximum. Okay, if you are maintaining the, ideally this this resistance is infinity. Ideally this resistance is infinity. Infinity means open circuit. No? Under open circuit condition, no current passing through the internal resistance. Am I right? If the resistance value is very less, at that condition, whatever the current supplied by the current source is passing through the internal resistance only. It is circulated inside only, no current passing through the load. It's clear. So what it means? What is the main concept here? To supply the current from current source to the load, so internal resistance of the source must be infinity. Current source, internal resistance of the current source must be infinity. Then only the current supplying from source to load. Okay. Current is always from passing through the low resistance path. Okay. If you are maintaining the high resistance here, then only the current is passing from source to load. Am I right or not? If you are maintaining the current is high resistance, then only it is passing through the load. Load resistance is less compared to this, then only the current is passing from source to load. Is it clear? Understood? If the load resistance is less compared to this internal resistance of the current source, then only the current is passing from source to load. It's clear? Understood? If the load resistance is less compared to this, then only this current is passing. If the load resistance is very high compared to this, then no current is passing from source to load. It's clear? So ideally, internal resistance of the voltage source is 0. Ideally, internal resistance of the voltage source is 0. Okay. Ideally, internal resistance of the current source is infinity. Okay. Practically, internal resistance of the voltage source is R. Practically, internal resistance of the current source is some R. Here, internal resistance of the voltage source is minimum. Practical internal resistance of the voltage source is, we have to maintain minimum. Okay. When current source, internal resistance of the current source is maximum. Then only the current is passing from source to load. Okay. So this is the current concept. So next concept we have to discuss in next class. Okay. So this is enough today.